unmanned vehicles. They're outside of an area that is completely unknown to them. Yet they're interested in fully imaging it at centimeter level resolution. But they only have Wi-Fi cards for imaging and no other sensors. The area can also have several occluded parts, and parts that are entirely behind walls and invisible to humans, robots, or any node outside. So this is a very fundamental problem of extracting information about our environment from wireless transmissions, and my group has been working on it for the past few years. So let's say the two robots move outside of the area of interest, while one transmits a Wi-Fi signal and the other one receives it. That transmission goes through the objects in the area of interest. Each object leaves a signature on the transmitted RF signal by interacting with it depending on its material property or location. But this information is very implicit and mixed up in the received signal. Also, there are lots more unknowns than the number of RF measurements that these robots can collect. So we have proposed a framework based on proper approximated wave models to capture what goes through the structure, sparse signal processing to address the huge size of the unknown space, and path planning. And we have shown that it's actually possible to do this task. For instance, here the robots are traveling 4 routes. We can see snapshots of their imaging results as they collect more Wi-Fi measurements. The robots do not coordinate anything while traveling each route. Each robot mathematically estimates its own position and where the other robot would be. At the end, they collect less than 2% Wi-Fi measurements, which means that we have a lot more unknowns than the number of collected measurements. Yet we can see that high-resolution imaging is achieved. We have tested our approach with several different structures and material. Here's a more complex and bigger structure. They can image that too. Let's say there's a human inside. Here's the high-resolution imaging result. The applications are very exciting and unimaginable, from robotic search and rescue to, let's say, a smart health monitoring system. Let's say that for an elderly monitoring, you use the existing Wi-Fi network to track the person. It's a really, really exciting time to work in this area because there's so many unanswered questions. And at UCSB, we have a great team of passionate students that are working to solve these questions.